This lesson focuses on covalent bonds, different types of those. Before we begin though, I want to focus on this, kind of cheesy diagram here. We have the two different types of bonds that we have, ionic and then covalent. Ionic bonds involve taking an electron from one atom and then, giving it to another. So it involves kind of stealing. But the one that got stolen from, it really doesn't mind because now that one also has an outer shell. Covalent bonds is sharing of electrons to make full outer circles of valence electrons. And that could be done equally or unequally, as we're going to be seeing today. So with the ionic bonds that we did last time, we took these two extra calcium electrons and we would give them to the chlorine because chlorine has 7, they're one away, so they each took 1. So now chlorine has that full outer circle of valence electrons of 8. Calcium now loses those 2 extra that it had, and then it goes to its previous outer circle, so calcium's also happy. To label that, you would do positive 2 for calcium because it took away 2 negatives, and then chlorine would each be negative 1, or just a negative up there because they added a negative. So now let's look at some covalent bonds. This is an example of a hydrogen covalent bond. We have 2 hydrogen atoms here. They each have 1 electron. They need to get 2 electrons in their outer circle to make a full outer circle. You could have one hydrogen give that to another one, but this would have actually absolutely no electrons. That just wouldn't work. So they have to share. So what you would do is you would kind of just rotate this one here, and then you would combine with this one. So you actually could write it like this if you're going to drag these up. And you put them between the 2 H's to show that they are sharing them. So this is kind of a neat way of hydrogen kind of getting the best of both. They share their electrons and now they have a complete outer circle, both of them. To show sharing, they don't really prefer you using 2 different dots. They prefer actually a line like this to show sharing. I'll have to move this back. So this actually shows a hydrogen molecule. An H with a line between, 2 H's with a line between it shows a hydrogen molecule. Just kind of keep that in mind as we're going forward here. Our next bond will focus on chlorine here. We have 2 chlorine atoms. They each have 7 electrons in their outer circle. We know they would like to get to 8. So what we can do is we can have one bond in the middle to create that 8th electron for both of them. When they're one away like that, you just have one bond. Just like hydrogen was one away each, you needed one bond to get it to a full circle. Chlorine is going to be the same way. One bond will fix this. So what we can do is actually take these ones, see they're all by themselves. We can make that the bond in the middle. So there they are, they're sharing these electrons. Then you actually can just move the rest of these over. And as you can see, the blue chlorine has 8 in its outer circle, and we can do the same thing to the red. Alright, so now we have 2 happy chlorine atoms making a chlorine molecule, is what that's called. And remember, like I said before, we don't want to have these 2 different colors together on the diagram. We actually want to put a line to show a bond. Let's move these over a little bit. So this shows a bond, a single bond between the 2 chlorines, forming that 8. This is another example of a single covalent bond. Water, H2O. We have 2 pieces of hydrogen. We have 1 oxygen. So we're going to have 2 single bonds kind of forming the rest of the oxygen because the oxygen wants these 2 molecules. Yeah, or I should say electrons. They want each of the electrons. So what we can do is we can put the hydrogen right here, hydrogen here, and then oxygen ones you can fill in the rest. And now oxygen is going to have its 8 and hydrogen is going to have its 2. Everyone wins in this deal. So hydrogen has 2. If you want to draw a circle here, see that? Hydrogen has 2. Oxygen has all 8. Hydrogen has 2. So that works out pretty well. This diagram here is a little bit off-centered, and we're going to talk about that in a little bit, how this is a polar bond, meaning it's a little bit unequal in the sharing. So what I'm going to do here first is actually delete some of these dots and put in the bonds. So these lines will represent the bonds here. So this shows a complete water molecule. The 4 electrons for oxygen, 5, 6, 7, 8. So each of these lines represents 2 electrons. So now we're on a double covalent bond, meaning that oxygen here needs 2 electrons each. Each of these need 2 electrons to fill an outer circle. But there's only 2 oxygen atoms, so there's no hydrogen to give it just 1 each like we had before with water. So what we need to have here is a double bond, meaning that these 2 stray electrons in each one, you can actually put them in the same area and have 4 electrons there. So what we can do, take this double, these 2 stray ones, take these 2 stray ones, and that's known as a double bond. And we have 1, 2, 3, 4 in the middle, so you only need 4 more, right? There they are, 1, 2, 3, 4. And what you do is you kind of make it one, you want to kind of want to keep it balanced. So this is actually how you would draw the double bond for oxygen. You have the double bond in the middle, then you have these 2 kind of forming a triangle and keeping it all symmetrical. So you do the same thing with the red here. All right, so now let's replace these with the lines to show double bond. So you have 2 lines now because it's a double bond. Kind of looks like an equal sign. So whenever you see an equal sign with the bonding, that shows double bonds. We have 1, 2, 3, 4, 5, 6, 7, 8 for both of these oxygen atoms, and they're both happy. And this would be an oxygen molecule. All right, one more double bond. We have carbon dioxide. When you have 1 and 2 like this, and you have a double bond in between, usually what you can do is you put the C in the middle, and then the O's on the outside, or you put the double on the outside like that. So we have 2, oxygen needs 2 each here. Each of them need 2. Carbon has 4 to supply. But carbon also needs to have 8 as well. So you basically have to double the amount of electrons for carbon. So what carbon can do is create a double bond over here. Create a double bond on this side. And then oxygen can bond over here with its spare electrons. So now count them for carbon. Carbon has 2, 4, 6, 8. Carbon's happy. Oxygen now. Oops, I didn't do that double bond right? You want to make it symmetrical, like a triangle kind of. And we'll do that over here too. And as you can count them for oxygen, you're going to count 8 in its outer circle then. These count for oxygen as well. So let's remove these and put a double bond for both of them. So double bond. So you got equal sign on that side. And we're going to be going double bond over here. Alright, so if you count them for each element here, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, and then it'd be 8 for carbon as well. So that's actually how you do a double bond for these ones. Let's move on to triple bonds. This is the only one we're going to show for this one. We have nitrogen now. So we're going to show a triple bond for nitrogen. Nitrogen only has 5 in its outer circle. So as you saw with oxygen, oxygen has 6 in its outer circle. It needed a double bond. Hydrogen had 5, it needs 3 more, so you would make a triple bond for nitrogen often, especially when you're making a nitrogen molecule. So for nitrogen, you're going to have 3 bonds in the middle. So these 3 stray ones here, put those over here. These 3 ones without a partner, you can put here in the middle too. And then to keep this balanced, I'm going to put these on just the opposite side of the bonds. And then these 2. So we have triple bonds in the middle. We have 2, 4, 6, 7, 8 for this nitrogen atom. And we have 1, 2, 3, 4, 5, 6, 7, 8 for this nitrogen atom. So this triple bond makes that possible. Now let's move all these out and move in the triple bond. And there, that's what that would look like. So this would be 1, 2, 3, 4, 5, 6. I'm sorry, 1, 2, 3, 4, 5, 6, 7, 8. And then this would be the same thing. 1, 2, 3, 4, 5, 6, 7, 8. Some of these bonds that we're making are going to be polar, and some of these bonds are going to be nonpolar. So that's what I want to kind of look at just for the end of the section today. When you make a polar bond, that means that you have much more positive charges over here, and you have more negative charges on the other side. It's unequal. So like this is a water molecule. We have a hydrogen with a positive charge, hydrogen with a positive charge over here. The negative electrons are over here. Then we have water, or we have the oxygen with all negatives on this side here. So when you hold up a positively charged balloon here, the negatively charged side of the water is going to be attracted to the balloon. We're actually going to do this tomorrow in class. So it kind of shows you that the negative charges of this side of the molecule are attracted to that positively charged balloon because it's an unequal, it's a polar bond. This would be a nonpolar bond. There's equal distribution of electrons and protons throughout that molecule. So that's something you could kind of summarize for yourself, and if you need any help with these bonds, just kind of rewatch the video or wait for me to give you some help.